Hello and welcome to my lesson in Sensing and Estimation in Robotics. My presentation will be based in the Springer's Handbook of Robotics. It will be divided in 4 main points. The first one is the perception process. The second one, the sensors. The third one will be the estimation process. And the fourth one will be representations. Well, in the perception process, we have the sensors taking information from the environment and the robot itself. With this information, we will make models, and if we have already a model, we will update it or match the data with the model. The problem is the preprocessing part. The preprocessing part is the part in charge of giving away the errors, systematic errors, are nonsense values. With the information that we have and the preprocessed information, we make a model and update the model, and we make the robot work without model. But how the sensors work and do this job? Well, the sensors can be classified in 2 different ways. The first one is by what they measure and how they measure it. We have the proprioceptors, which are the ones that measure the robot itself, its position, rotation, or the exteroceptors, which are the ones that take information from the environment. We can also divide the sensors in other class, which are active or passive ones. The active are the ones that give some kind of energy or signal to the environment and catch the reaction of the environment to that signal. Usually, these are the exteroceptors, which can be contact or not contact ones. And the passive ones are normally proprioceptors and are the ones that are not active. We can measure with this the ego motion with accelerometers on gyroscopes, but we use these accelerometers and gyroscopes in international measurements units. This method has a problem, which is the need of the double integration. We can have also ultrasonic sensors like radars, laser scanning sensors, or imaging sensors like CCD or infrared or ultraviolet sensors. With the information that the sensors provide, we go now to the estimation process. Making a model of the environment and matching data with the estimation process is really important because we don't have the capacity or ability to make a perfect model of the environment. Normally, the problems we have in this estimation is the so-called problems of decision or decision problems. These problems can be reduced to a 0-1 response. I mean, yes or no response, to cross or not a door. Common techniques to the estimation process are the maximum estimate or the Kalman filter. The Kalman filter is used in 3 different ways. The first one with the linear relationship between the information, the extended Kalman filter for non-linear relationship, and the iterated extended Kalman filter for better non-linear response. Making a sensor model consists in 4 parts. Having a physical model, determining sensor calibration, determining error model, and identifying failure conditions. Other methods that we can use and are also successful are constraint-based methods for point estimation, and with this information we make representations. They're usually 4 common representations: the raw sensor representation, the grid-based representation, the feature representation or the symbolic and graphic-based models. The raw sensor representation is used when it's not necessary to have a world model of the environment. Proprioceptors use normally the raw sensor representation. The grid-based representation is when we have a large scale and inhomogeneous data. The feature representation is used to provide uncertainty from point and line models in a low, really low scale. And symbolic graph-based models are a mix of points and edges in which we can associate it with information like distance, depth, and length. Well, I repeat, we have the perception process, the sensors, the estimation process, and the representations. I hope you have understood my lesson, and if you have any questions, please ask me. Thank you very much.